Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue on the next topic on the measure of dispersion, which is variance and standard deviation. So basically, variance and standard deviation are most popular measure of dispersion, right? So the symbol for variance is, let's say for sample variance is S squared. For population variance is sigma squared. So the value of standard deviation is actually a square root of variance. So we can compute variance and standard deviation for both sample and population, right? So in this chapter, we will only cover for sample, standard deviation, and variance only. So the definition of variance is a sum of square of the difference between each data value and the mean divided by the sample size minus 1. So this is a definition of variance for sample, right? Sample statistics. So basically, we have two formula, right? For ungrouped data, to calculate variance, we have two formula. This is a formula number one. S square is equal to summation of x minus x bar, and then you square divided by n. Right. Another formula is S square equal to summation of x square divide minus summation of x, and then you square divided by n, and everything divided by n minus 1. So bear in mind, this is formula number one. This is formula number two. So we're not going to use formula number one because this is going to be very tedious calculation. So we're going to omit formula number one. So we're going to use formula number two. Right? So we're going to use formula number two. And if you look at formula number two, summation of x square minus summation of x, then you square, right? Divide by n, then everything divided by n minus 1. So you need to understand summation of x square is not equal to summation of x and then you square. So it's totally different value. So if you want to find the standard deviation, so we just take a square root of variance. So it's equal to standard deviation. That's why for this formula, we just take a square root of variance. We will get standard deviation. So this is the formula for ungrouped data. For group data, right? For group data, we also have two formula. This is formula number one, right? Formula number one, and then this is formula number two. Right, so we're going to omit formula number one, and we will use formula number two. Right. So always use formula number two, and for this formula, the formula is summation of fx square minus summation of fx, and then you square divided by summation of f divided by summation of f minus 1. Again, summation of fx square is not equal to summation of fx and then you square. It's totally different value. So when you have a frequency table, and then you need to use this formula table and this formula value, right? And then if you have ungrouped data, you need to use the formula for ungrouped data. Like let's move to example number 42. For example number 42, the following data calculate the variance and standard deviation. So we have basically 1, 2, 3, 4, 5, 6 data. So n equal to 6. So once you have ungrouped data, my advice is you to table the data, right? So you can see, you can calculate for the x square. So this is your x and this is your x square, right? And then first is 3, 6, 9, 12, 15, and 18. And the last is total. Total. So the x square, this one should be equal to 9, 36, 81, right? And so on. Where is my calculator? So 112 multiplied with 12 is equal to 44. And this is 15 multiplied with 15. Sorry. 225. And 18 multiplied with 18 is equal to 324. Right, and then you need to find the total. So this one should be summation of x is equal to 63, and summation of x square is equal to 819. So this is summation of x, and this is summation of x square. So by looking at the formula of sample variance, the summation of x square minus summation of x, and then you square, divide by n, and everything divided by n minus 1. So you input the value into the formula. So this is going to be 819 minus 63 square divided by, the number of observation is 6, right? So divide by 6. Everything divided by 6 minus 1, which is equal to 5. So this one should be equal to 31.5, right? So this is the variance for the sample. So this is what we call a sample variance. So S square is equal to 31.5. So if you want to find the standard deviation, we just take a square root of standard deviation, which is the square root of variance, which is 31.5, is we're going to be equal to 5.612. So this is sample standard deviation. Right. So are you clear with this one? We to calculate variance and standard deviation from ungrouped data. Can you comment if you clear? If you have a question, you can raise a question in a chat room. Are you okay? Can you comment? Right, good. So now we move to the next example, which is example number 43. So this is basically group data. So we have number of children, which is X, and number of family, which is frequency. So now, since we have a frequency table, right? So look at this frequency table. We don't have a class size for each class, right? We have a point value, right? So my advice is you need to transform this table, right? Let's see. Right. So create a table. You need to transform the table. So let's say I transform this table to the long format, from a wide format to long format. So right. So for the first one is number of children, and the second one is number of families. Right. So this is your X and this is your F. So since this is a group data, so calculating sample variance should be equal to summation of fx square minus summation of fx, and then you square, divide by summation of f, and everything divided by summation of f minus 1. So this one is 0, 1, 2, 3, 4, right? So you will have 5 rows representing the class. So last is the total, right? So this is 5, 12, 14, 10, and 9. And the summation of f is equal to, if you summation is you add every number of frequency here, you should get 50. And then according to the formula, you need to find summation of fx square and summation of fx, right? So next we need to find fx, and the last one is fx square. So fx is equal to, this one should be 5 multiplied with 0 is equal to 0. This is 12, 28, 30, and last is 36. And the summation of fx is equal to 106. And then this is x square should be equal to 0, 1, 4, 9, and 16. So f multiplied with x square. So should get 0, 5 multiplied with 0, and then 12 multiplied with 1, it should be equal to 12, and 14 multiplied with 4, it should get 56, and then this is 10 multiplied with 9 equal to 90, 9 multiplied with 16 should be equal to 144, and then you add all the value here, should get 302. So once you calculate each value in the table, and then you can easily know that summation of fx square is equal to 302, and summation of fx is equal to 106, and the summation of f is equal to 50, right? So now once you have all the value, you should plug in the value into the formula. So this is summation of fx square is 302 minus 106, and then you square this one, divide by 50, everything divided by 50 minus 1, right? So this is how you calculate sample variance. So this one should lead you to 1.577, right? To find the standard deviation, you need to square root of variance. This one should be equal to square root of 1.577, right? So equal to 1.256, right? Or equivalent to 1 children. So this is how we calculate sample variance and sample standard deviation. Right? Do you have any questions so far? All right. I hope you understand. Right? This is very easy to calculate sample variance and sample standard deviation. Right. So now I'm going to show you how to calculate variance and standard deviation using calculator. This is going to be save your time a lot, right? And save your possibility to make a mistake, right? So let me unshare this one first. Stop sharing, and then right now, can you see my slide and calculator? Right? Can you see the slide and calculator? Yeah, very good. Now, you see, to calculate variance and standard deviation using calculator, this is a calculator of 570 ES. So this is the ES calculator, right? So first, you need to clear all the memory. To clear all the memory, click on Shift and then 9. And then dia akan keluar this one. So click 3 and equal and click AC. Follow the step. So we need to clear all the memory first. And then, so you need to understand this is a frequency table, right? So we have X value here, X value, right? And we have the F value, right? We have F value. So now You see? Nampak kan? Okay, buka besar sikit. Alright, nampak kan? Besar sikit kan? So now, first step you click on mode, right? Sorry, first step you tekan shift mode. Right, ulangan, shift mode. Right, so this is the first step. So you akan nampak this one mat IO, line IO until norm. So you tekan, nampak dekat atas ni dia tulis arrow down. So tekan bawah ni, and then you akan nampak 4 for start. Ataupun kalau calculator you lama sikit, you akan nampak mungkin start tu tempat lain lah. So just cari start, tekan 4, and then this is dia akan tanya whether you want to on frequency or off frequency. So you tekan 1 lah untuk on frequency. So once you dah tekan on frequency, now the second step is tekan mode, and then you cari start nombor 3, right? Ataupun maybe start on number 4, it depend on your calculator. So cari start which is number 3, so tekan 3, and then now you akan cari 1 minus variance, right? So you nak cari satu kolom, satu value saja untuk cari variance. So tekan 1 lah, 1 minus variance. So now dia akan nampak macam ni. So dia ada X column and frequency column. So next thing is you need to click the value, you need to input the value lah. So for X equal to 0, right, atas sini, frequency equal to 5, right, boleh. So now you key in everything. So this is 1, 2, 3 and 4, right. So this is 5, and then next equal to 12, and then 14, and then 10, and then the last one is 9, right. So by using this calculator, you can check your input, whether you are correctly input all the data in the table, right. So the first one is 0, 1, 2, 3, 4, and the frequency is 5, 12, 14, 10, and 9, right? So once you are already input all the data, tekan AC, right? So now what we need is in your final exam or your test, right? So I require you to write down the value of fx square, summation of f, and the summation of fx, right? So now tekan shift and then tekan 1. You see, nampak tak dia tulis start dekat atas 1 ni, tekan 1, and then now you tekan sum nombor 3, right? So bila you tekan 3, dia akan keluar summation of summation of x and summation of x square. So summation of x is the value is representing summation of fx. So kalau you tekan 2, you akan dapat 106. So you need to remember, right, in calculator, summation of x is equal to summation of fx in calculator, right? And summation of x square is equal to summation of fx square, right? So kalau tekan shift 1, tekan 3 untuk sum, and tekan 1 untuk x square, so dia akan keluar 302. So you need to remember summation of x square is equal to summation of x, right? And for this one, we cannot find summation of f, right? By using this one, we cannot find summation of f. But never mind, you can always calculate summation of f from calculator. 5 plus 12 plus 14 plus 10 plus 9. So this one should be equal to 50. So we already know summation of f equal to 50. So now, I require you to write down the value, right? So you should always write down the value of each parameter in the equation, right? So once you write down the value, you need to input all the value into the formula like this, right? As x square equal to 302 minus 106 square divided by 50, everything divided by 50 minus 1. Right, so now you even no need to calculate the value inside the formula. So you just tekan on, tekan shift, tekan 1, and then now you cari 4 untuk variance, right? Now you akan nampak dekat sini, for the new calculator you akan nampak sigma, the first one is n, right? N adalah 50. This is, kalau you cari n dalam n equal to summation of f dalam calculator, right? Just nak emphasize balik, ulangan sebalik, kita nak cari summation of f, so just tekan shift 1 4, so dia calculate n dekat sini, so n is summation of f, right? So you don't need to calculate one by one again. So to find the value of variance, right? So you tekan shift 1, tekan 4, right? So you nampak dekat atas ni, last time kita dah buat kan untuk cari mean. So tekan 2 untuk cari mean, right? Tekan 3 untuk sigma x, right? And tekan 4 untuk sx. So dekat sini, sometimes all calculator dia akan tulis n sigma minus 1. Sorry, n sigma minus 1, and another one is n sigma. So dia ada dua, ada all calculator, right? So this is a population standard deviation, right? And this is a sample standard deviation. For our calculator, right? For the new calculator, sigma x is the population standard deviation, and sx is representing sample standard deviation. So if you click on 4 sample standard deviation, it will give you the value of standard deviation, right? So 1.26, right? So now, if you want to find the value of variance, you need to square this one. Tekan square lah. So this one should be equal to 1.577, right? So this is how you want to find variance, sample variance and sample standard deviation, right? So far, are you clear how to use calculator? Can you comment? Please comment on the chat room. Right, good. So next, we move to the example number 44, right? In example number 44, right, we will try to use calculator, right? Calculate the variance and standard deviation for monthly income of 50 employee in the firm. So explain the meaning of value of standard deviation obtained. So this is the value of summation of f, right? So this is your class and this is your frequency. So since you in your each class have a class size, you need to find the value of x. The value of x is representing midpoint, right? Midpoint. So how to get midpoint? 500 plus 700 divided by 2. So 500 plus 700 divided by 2, it should be equal to 600, right? So this is 600, this is 800, this is 1000, 1200, 1400, right? So remember, since this is a frequency table, this is a group data. To find the variance is summation of fx square minus summation of fx, and then you need to square, divide by summation of f, everything divided by summation of f minus 1. So now we want to find summation of fx square. summation of fx, and summation of f. Remember, each value you input in your answer sheet, you will get 1 mark, right? Sorry, half marks. So now, again, to find this value, just click on Shift 9 to clear all the memory, right? Click equal AC, right? So next we click on Shift Mode and find stat number 4 and click on frequency. So next step is we click on mode and find stat and find number 1 minus variance. So tekan 1. So we input all the value in X column. So 600, and then this is 800, and this is 1000, 1200, and the last one is 1400, right? And then we input, all right, and then we input all the value of the frequency column. 4, 6, this is 15, this is 18, and the last one is 7, right? So we can always recheck all the value that we input in the table: 604, 806, 1015, 1218, and 1407. Right, once done, we can click on AC, right? So next step is we click on Shift 1 and find the value 3. So summation of x square, fx square is summation of x square, tekan 1. So you will get 5,599,000, berapa tadi? 599,200,000, right? And then we need to find summation of x, fx, tekan 3, and then tekan 2, right? So 53600, right? To find summation of f, tekan shift, tekan 1, tekan cari variance number 4, and tekan 1. So actually dia dah bagi tahu kat sini, this is a summation of f. So itu saja nak tunjuk dekat you, this is 50. So once you got all the value, just input the value into the formula, right? So x square should be equal to 599,200,000 minus 53600 power of 2 divided by 50. Everything divided by 50 minus 1, right? So the value of variance, cari dekat sini, tekan shift, tekan 1, tekan 4 for variance, and then cari SX, ataupun you kena cari N sigma minus 1. Sorry, sigma N minus 1, I think. Either these two, right? So cari number 4. So this one should be equal to 224. So remember, this is not a variance. This is a standard deviation. So you need to square this one. So you will get 50,220.41. Right. So to find standard deviation, it's just a square root of 50220.41 equal to, so you tekan ni lah, is equal to 224.10. Right. Okay. So what does it mean? Right. The standard deviations tell us the deviation of monthly income of 50 employees from mean monthly income is 224 ringgit. Right? The deviation of the monthly income of 50 employee from the mean income is RM 224.10. So this is how you interpret the value of standard deviation. Right. So far, do you have any question? Can you comment on the chat room if you have any question? Any questions so far? Comment on chat room. Right. I hope you understand. This is very simple topic, but it actually so if you don't interpret, we are going to lose mark. No, actually it depends on the question. If the question require you to interpret the value of standard deviation, then you need to interpret. Then it will give you marks. If you are not stating, they not require you to interpret, then you don't need to interpret. Simple as that, right? Okay. Any? So I hope you understand, right? Later I will show you how to use calculator, old calculator, MX 570 MS later lah. But I hope you will use the newest calculator because it will save you from making a mistake. But you can also use the oldest calculator, which is MX, right? Nanti I akan tunjuk dekat you on another video dalam YouTube, no worries. Right. So now we move to the next topic, which is coefficient of variation. So coefficient of variation, right, is when we want to compare the dispersion or spread of variability or more than two data distribution. When we have more than one data, let's say more than two data, right? Data distribution. So we want to know whether the first data distribution is spread, more spread or more dispersed compared to another distribution. We should use coefficient of variation. As I said yesterday, right? Let's say I have two two sample, right? Let's say this is a sample number one, children from playground A, and this is children from playground B, right? So both having a mean equal to 5, right? Mean equal to 5. And let's say the sample standard deviation here is 2.5 and sample standard deviation here is, sorry, let's say this is 1.5 and this is 2.5, right? So we can say that from here, if you have this value, mean and standard deviation for both data, we can say that when we have equal mean, right, and mean for this distribution, and then the standard deviation, the distribution that have a lower standard deviation should reflecting consistent result. Means the observation are all around the mean, right? The spread ataupun the dispersion of the data is low, right? So if you look at the distribution B, the standard deviation is 2.5, which is higher than A. We can say that the dispersion of observation in data distribution B is more spread, right? Dia akan lebih mencapah lagi, dia tak tertumpu, they're not consistent, right? So we want to know, when we have two distribution, we want to know which distribution have consistent distribution or which distribution had dispersed observation, right, around the mean. So we can use coefficient of variation to compare between two distribution. So coefficient of variation is a relative measure of dispersion, and it compare the standard deviation and mean for the distribution and convert it to the percentage, right? So this is the formula for coefficient of variation, COV, right? Ataupun CV. Better kita pakai the term COV, right? Kita omitkan CV ni. Kita pakai COV to represent coefficient of variation, right? So tapi we mungkin akan confuse dengan covariance, but it's okay. But in our class, we use COV for coefficient of variation. So coefficient of variation, the formula is sample standard deviation divided by sample mean, multiply with 100%. So if the coefficient of variation of distribution A is greater than the coefficient of variation in distribution B, right? Means coefficient of variation A is greater than coefficient of variation distribution B, then we can say that the distribution A is more dispersed or more spread compared to distribution B, right? Maksudnya dekat sini kita boleh kata, let's say when we calculate the coefficient of variation, let's say coefficient of variation A here is standard deviation divided by sample mean multiplied with 100%. So this one should be 1.5 divided by 5 multiplied with 100%. This one should be equal to 1.5 divided by 5. 100% is equal to 30%. Right? For coefficient of variation B, S divided by X bar multiplied with 100%, and this one should be equal to 2.5 divided by 5 multiplied with 100%. This one 2.5 divided by 5 multiplied with 100%, it should be equal to 50%, right? So now we can say that coefficient of variation here is coefficient of variation distribution B is more than coefficient of variation distribution A. So we can conclude that distribution B is more dispersed or spread compared to distribution A. Ataupun kita boleh kata distribution A is more consistent compared to distribution B. Right. So this is how we interpret coefficient of variation. Right. So now we look at example number 45. So before we go to example, do you understand the concept of coefficient of variation? Right. Can you comment a bit? Do you understand? Can you comment? Do you understand concept of coefficient of variation? Yeah. Good. Okay, good. So now we move to example number 45. So this is a very simple example, right? So in example number 45, given the following statistic for the distribution, statistic without S, right? For the distribution A, B, and C. Distribution A, so let's say we put like this, A, B, and C, right? Distribution A, we have mean equal to 15 and standard deviation equal to 5. Distribution B, we have mean equal to 30 and standard deviation equal to 18. Distribution C, we have mean equal to 25 and the standard deviation equal to 10. So remember, in coefficient of variation, we need to find standard deviation divided by mean, multiply with 100%. So you don't need to confuse standard deviation and variance. Variance is S squared. We want to find standard deviation only. Right. So now we calculate coefficient of variation A as divided by x bar. So this one should be 5 divided by 15 multiplied with 100%. Right. So this one should be equal to 33.33%. And coefficient of variation B, this one should be equal to 18 divided by 30 multiplied with 100%. Right. So this one should be equal to 60%. Coefficient of variation C, this one should be equal to 10 divided by 25 multiplied with 100%. This one should be 40%. So what can we conclude from here? We can see coefficient of variation A is the smallest value coefficient, and then followed by coefficient of variation distribution C, and the last one coefficient of variation distribution B. So this is 33.33%, this is 40%, this is 60%, right? So we can say that distribution C is more dispersed compared to distribution A, right? And then we can say distribution B is more dispersed compared to distribution C and A, right? And from all distribution, we can say that distribution A is more consistent compared to distribution B and C, right? Distribution A and B, sorry, A and C. Sorry, this is this is betul. Distribution C is more dispersed compared to distribution A. Distribution B is more dispersed to compared to distribution C and A. And distribution A is more consistent compared to distribution B and C. So this is how we can interpret coefficient of variation, right? Are you okay? Now, we move to the next example. This is example from a raw data, right? So usually the question in the final exam and test should be like this, right? Example number 46. So the following data, do you have any question? No question. Right. The following data show the monthly income of the employee of company A and company B. So company A, we have 1,200 until so on. This is how many N? NA 1, 2, 3, 4, 5, 6, 7, 8. So NA equal to 8. NB, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So we want to know which company has more consistent monthly income. So we want to show this using appropriate calculation. So now we put like this: company A, and then this is company B, right? So now I'm going to show you how to use calculator. We don't need to calculate one by one, right? You can see my calculator, right? So now we tekan shift 9 and 3 untuk clear all the memory. Right. So since this is a ungrouped data, right, you do not need to on the frequency, right? You just click on mode and find 3 untuk stat and cari 1 untuk 1 minus variance. So dia akan close single column saja, right? So 1 2 0 0 masukkan dalam this one, 2 3 2 0 0 and 2 8 0 0 1 4 0 0 9 5 0 3 5 0 0 2 5 0 0 and the last one 1 1 2 0, right? So you boleh check balik apa the value yang you key in. So first we want to find x bar. X bar is equal to summation of x divided by n, right? And another one is we want to find standard deviation, which is equal to summation of x square minus summation of x, and then you square divided by n, everything divided by n minus 1, right? So the value that we want to find is summation of x and then summation of x square and the value of NA, right? So this is the 3 value that we want to find. So for the company A, once you already key in the value, right? So you tekan AC, now you tekan shift, tekan 1, and tekan cari 3 untuk sum, right? So you cari summation of X, nombor 2. So this is 16670, right? And summation of X square, number 3, 1. So this is 4. Berapa ni? 4213690, right? And number of observation is equal to 8. Now we just need to input the value in the formula 16670 divided by 8. So the value should be equal to, tekan shift 1 5, shift 1 4, cari number 2 x bar, right? So this one is 2083.75, right? And then this one, just plug in the value 4213690 minus 16670, and then you square this one, divide by 8, everything divided by 8 minus 1, taking a square root, right? You can shift 1 4 and cari 4, right? So this one you don't need to square because we are looking for standard deviation. So this is 1028.23, right? We are going to do the same step. We're going to repeat the same step for company B. So x bar equal to summation of x divided by n. So S is equal to summation of x square, summation of x, and then square divided by n, everything divided by n minus 1. So we want to find the value of NB, summation of x, and summation of x square. Right. Again, the same process. We need to clear all the memory, right? And tekan mode, cari 3 untuk start, and 1, right? So now kita input the value 950 2200 4000. Right. So we have 10 value. You can always recheck the value that we key in into the calculator. 4000, 2050, 3200, 1500, 1725, 1500, 1250, right? Now we can find the value easily. 3 summation of x equal to 220 175, is it? Right. And then summation of x square 3 1. So this is 48 48 46 3125. So this is 20175 and this is equal to 10. Right. So once you got the value, right, just plug in the value into the formula. Right. Plug in the value into the formula. This is 20175 divided by 10. So this one should be equal to berapa? Tekan shift, tekan 1, tekan 4 and cari mean for number 2. This is 2017.5. Right, so this is the value of mean. And next is we need to input the value 48463125 minus this is 20175 and then you square this one, divide by 10, everything divided by 10 minus 1 square root, right? Tekan shift 1 and 4, tekan number 4 untuk sample standard deviation. So this one is 928.56. Right. So you already got the value for each company, right? So once you got the value for each company, now we can calculate the coefficient of variation. So the coefficient of variation, company A is equal to, the standard deviation is 1028.23 divided by 2083.75 multiply with 100%. So this one should be equal to 49.35%. The second one is coefficient of variation, company B. This is 928.56 divided by 2017.50 multiply with 100%. So this one should be equal to 46.03%. Right. Wait, I'm stop sharing this one first. Wait, I stop sekejap, dalam 2 minit, sekejap lagi kita sambung balik. Alright, kita sambung balik sikit lagi. Right, so from the coefficient of variation, you nampak I punya slide? Right, you nampak slide I? Tak nampak? You nampak slide I? Nampak, right, good. So once you got the value of a coefficient of variation, right, so we know that coefficient of variation company A is 49% and coefficient of variation company B is 46%. So we can say that coefficient of variation B is the smallest compared to coefficient of variation company A. And we can say that monthly income monthly income of employee in company A, company B lah, B is more consistent compared to monthly income in company A, right? So since the COV coefficient of variation of company B is the smallest compared to coefficient of variation in company A, so company monthly income of employee in company B is more consistent compared to monthly income of the employee in company A, right? So I hope you understand this one, right? So far, do you have any question? Right. So now, look at characteristic of measure of dispersion, right? So some characteristic of measure of dispersion are the more spread out or dispersed the data are. So the range will be larger, the interquarter range will be larger, the quarter deviation also large, variance and standard deviation also large, right? So the more clustered the data are, means the more consistent, maksudnya data tu tak disperse. This is disperse, mesti dia akan nampak macam disperse sikit, besar. So data dia akan disperse around the mean, right? So this is disperse. So, kalau dia clustered means dia akan bentuk macam ni, right? So data dia akan lebih tertumpu, right? So the more clustered the data, the range value, interquartile range, quarter deviation, variance and standard deviation akan jadi kecil, very small, right? If the data value are same, that is there no variation in the data and the range also no, they don't have a range, right? Kalau data maksudnya data tu tak disperse, maksudnya the data will get macam ni saja, right? So this is your mean, this is mean. So data semua dalam satu straight line, right? So means there are no range, there are no standard deviation, there are no interquartile range, variance and deviation, right? So the most important thing is you need to understand the range value, interquartile range, quarter deviation, the variance and standard deviation can never be negative. So this is the most important characteristic of measure of dispersion, right? So I hope you understand this one. So we have our last topic on measure of dispersion, which is coefficient of skewness. Can we move to? Can you continue for this one, measure of skewness? So once we finish a measure of skewness, and we finish chapter number 3. Are you okay? Can we move? Right? So now we move to the measure of skewness. Right? In measure of skewness, we already know in previous topic, in measure of central tendency, when we have from negative infinity to infinity, right? When the mode is smaller than median, this is mode, smaller than median, smaller than mean, maksudnya the mean is a larger value, then we have skewed to the left. When we have larger mode, maksudnya mode is over here, right? Mode is a large than median, large than mean. So we have skewed to the, so this is skewed to the right, and this is skewed to the left, right? It's skewed to the left. And when we have a same value of mean, median, and mode, this is mean, mode, and median. So we have symmetrical distribution, right? So this is based on characteristic of measure of central tendency, mean, mode, and median, right? So let's say in a question I ask you to find mean, and then I ask you to find median, and I ask you to find standard deviation, right? So we don't really have all the statistic measure. What we have is measure of median, mode and median, mode and mean, and standard deviation, median and mean, and standard deviation. So we can also find the skewness of the distribution by using Pearson coefficient of skewness. We have two formula: Pearson coefficient of skewness number 1 and Pearson coefficient of skewness number 2. You can use either one. For number 1, mean minus mode divided by standard deviation. Another one is 3 multiplied with mean minus median divided by standard deviation. So now the value of coefficient, if the coefficient of skewness are positive, if the value you got a positive value and you input the data into, you input the value into the formula, you got positive value, then we can say that distribution is skewed to the right distribution. When the coefficient value is negative, then you will say that the distribution is skewed to the left distribution. When the coefficient of skewness equal to 0, then the distribution is symmetrical distribution or normal distribution. Right. So this is the characteristic or how to interpret from Pearson coefficient of skewness. Right. So now we move to example number 47. So in example number 47, right, I just don't want to repeat to calculate this one. I will give you the answer. For the following data, show the aptitude test score for 40 candidates, right? So we have summation of F equal to 40. So this is F, and this is your class size, and this is your X. X should be this should be 24.5, 34.5, 44.5, 54.5, 64.5, 74.5, and this is 84.5. Right? So the summation of fx should be equal to 2370. Summation of fx square is equal to 147820. Right. So the mean and standard deviation of the score, the mean is equal to, let's say I give you the answer, nanti you buat sendiri, you calculate sendiri. So this is a 59.25, and the standard deviation is equal to 13.77. And the model value you need to find by yourself. I give you the model value. The model value is 57.83. So this is equal to mode. So now if you want to find the shape of distribution, so since we have the value of mean, mode, and standard deviation, we will use coefficient of variation, like coefficient of skewness number 1. Right, which is equal to x bar minus mode divided by standard deviation. So this one should be equal to 59.25 minus 57.83 divided by standard deviation 13.77. So this is a positive value 0.103. So since this is a positive value, we can say that the distribution, the score distribution is skewed to the right because we have a positive value, right? Okay, let's look at another example. This is going to be our last example, right? So the following data show monthly sales, right, of 30 sundry shop taken randomly from town X. So let me give you the answer, right? Later you do it by yourself. This is going to be your homework. I just want to show you how to calculate, how to determine the shape of data distribution. So the mean here is equal to 8,667, and the median here is equal to 8.167. So this is mean is equal actually 8.667 lah, right? So when we convert to 1,000, it's going to be 8,667. So we choose one value, right? So the mean is 8.667, right? So the standard deviation here S is equal to 2.482, and we want to determine the shape of data distribution. We will use coefficient of skewness number 2. So the coefficient of skewness number 2 formula is 3 multiplied with mean equal to 8.667 minus the median is 8.167 divided by standard deviation, which is 2.482, is equal to, this is a positive value, 0.604. So since the value of coefficient of skewness is positive, then we can say that the shape of data distribution is skewed to the right. Right? So we got skewed to the right because the coefficient of skewness is positive, right? And then we can calculate the coefficient of variation. You calculate by yourself this one, right? I already taught you how to calculate coefficient of variation. So I leave it this example number 48 as your homework. You can do it by yourself. Right. So far, do you have any question before we end our session? Any questions so far? Right. So I think that's all. So I will end our session right now.